For number 48, we're going to use properties of logarithms to expand the logarithmic expression as much as possible. And where possible, we're going to evaluate logarithmic expressions without using a calculator. So here we have log base b of xy squared over z to the 5th power. So we need to know our properties of logarithms. So I'm going to write like a little review here. So basically, with logarithms, when you have a logarithmic expression, division will turn into subtraction between logs, multiplication will turn into addition, and then exponents, so I'm going to draw a little arrow for exponents, will turn into something out in front. So let's write that as a coefficient. So let's have this as a little guide. And I suggest if you have yours written out in your binders or in your index card to have them out and try to memorize them as best as possible, because they definitely become very useful once you just know the rules. So with the log base b of xy squared over z to the 5th power, we see that it is a fraction. And because it is a fraction, we can turn it into subtraction between two logs. So we're going to take this and we're going to turn it into the log of the numerator, which is xy squared, minus the log of the same base of the denominator, which is z to the 5th power. Now let's take a look at this first log that we have here and try to expand just that log. So here we have inside of the log, we have x times y squared. Notice that the square is only affecting the y. It's not affecting the x and the y. It's just affecting the y. So therefore, the two factors we have here are x and y squared. So this is multiplication, which we can therefore turn into addition between two logs. So this is going to turn into log base b of x plus log base b of y squared. Now remember, we're only working with this log right now. So that turned into two separate logs, giving us log base b of x plus log base b of y squared. Log base b of x has nothing else that we can expand it for, so that's just going to stay the same. Log base b of x. And then log base b of y squared has an exponent, and we know exponents can turn into the coefficient of that log. So we're going to bring that out in front, giving us 2 log base b of y. And therefore now this is something that we can't expand anymore as well. So therefore now we're done here. Let's take a look at the next log, the log base b of z to the 5th power. We can expand that because it has an exponent, which we can move out to the coefficient in front of the log. So let's go ahead and do that, and let's not forget to bring down our negative sign. So this is going to turn into 5 log base b of z. And there's nothing more that we can do to that log as well, so that's going to be part of our final answer, which is log base b of x plus 2 log base b of y minus 5 log base b of z. And that's the most expanded form you can have for this logarithmic expression using the properties of logs.